Hello everyone. Can you hear me?
Yes, we can.
Yeah.
Yes, ma'am.
Okay, great. Good evening everyone, and welcome to the fourth live session of Introduction to Biostats course. So, just a couple of things to wrap up what discussions we had until now. So, last time we saw that there were a few questions in the first and second assignment that either had some confusion about the solution, the formula used, or whether the topic was exactly taught in the lectures or not. So, this has been conveyed to the instructor. So, they'll sit with the team who's making the questions and everything, and it will be sorted in due course of time. All right. So, and of course, as the participants, if you ever think that there is some confusion, any question you feel is out of syllabus, or the formula used or the solution that's not correct, you just let me know or let one of the other TAs know. Put it on the discussion forum, tell it in the live sessions, and then it'll be conveyed. All right, so that's one thing. And also, so just to reiterate, since sometimes our discussions go into quite basics of what is already taught, so discussions are good, but these live sessions are not exactly meant to teach the whole course again. You have the lecture videos, so it will be good if you have already watched the videos before attending this session. And this video, it's anyway being recorded, so in case you have not watched a session, you can always watch the videos first and then take a look at the recording of this session, because then it will be better, because a couple of last week and before that we exceeded the time by 15-20 minutes, and we still were left with a few things. So it's just better if we are sort of a little prepared what the week has been about, and then we are just discussing those. All right, that discussion can go on for as long. Yeah, so that's all I had to say before we start this session. Do you have any doubts, anything you would like to talk about before we start today's class? Yeah. Okay. All right, so if there's nothing to discuss, I will just share my screen. I hope you can see the screen. All right. So,
Yeah, excuse me.
yeah.
I am having not doubt here, you can say.
Mm-hmm.
I just want to know the idea or the concept behind how to learn all the formulas, how to like when the syllabus is going and on, na? So you
Uh-huh.
are just in a way forgetting the previous ones, and sometimes I get confused also that
Yeah.
which
Yeah.
formula will apply. So is there any trick or you can guide us through that thing because you're a
Uh,
student
yeah.
doing
Yeah.
this.
Yeah. Yeah.
Yeah.
So, so
What is
one
the trick
thing,
behind to how to prepare for the exam, how to
yeah.
prepare for the things which we are like coming in the days. The thing is, uh, one thing I want to
Mm-hmm.
like discuss is in the day-to-day life when we are doing research things, na? So we are using softwares like SPSS, R and all the things.
Yeah.
So that is the separate thing we are applying, like कि हमें कौन से टेस्ट लगाने हैं,
Mm-hmm.
क्या पता होना चाहिए कि इसमें क्या चीज निकालनी है, what we have to evaluate in that.
Yeah.
But in this thing, theoretical thing है ना, we are
Mm-hmm.
not that much adapted to do
Yeah.
these things. So how to go through all these so that we can make such notes preparing. I do make notes while
Yeah.
taking the lectures, but still
Uh-huh.
I got confused at so many times.
Yeah. So the first thing that I was anyway going to say was to make notes. So like having all the formulas at one place, um, that you can decide like topic wise, or yeah, I mean topic wise makes the most sense. And that's one thing. And the second thing is, if you sort of fall out of practice, you are bound to forget. And that goes for anything, right? It goes for maths formulas,
Mm.
any other subjects, formulas, anything you're doing, like even computer codes or working in the lab, that applies for
Sometimes
anything,
sir is
right?
telling actually he's deriving the things na,
Uh-huh.
that equations and all. So midterm steps also we need to like learn those all steps also. We need to know the derivations also, or the end formulas are sufficient.
Yeah, no. So for the purpose of the exam, you don't need the middle steps, because your exam is going to be just like these assignments, right? They are going to be objective questions, either options, or you will have to just write
That
decimal
I know.
values, right?
Yes.
So as such, these middle things you don't need, but uh, they are helpful if you are forgetting the last step. But if you remember the starting and if you know the concept, you can derive it, right?
Hmm.
So it's, I mean, it's not a universal thing. If you are, depends on um if the exam is, if you are preparing for just the exam, um sometimes we'll just mug up formulas a day
Hmm.
or two before the exam. You can just mug them up and um use it. Sometimes, especially if this topic is going to be useful for you once you start applying this, not directly. So it's not every day that you're going to need to use the formula for standard deviation, right? But maybe like you're working and once a month or once in 2 months you come across this, so you remember, okay, at least you read about it, you understood it at some point of time, so you can revisit this. You have resources online, these lecture videos are there for you, so you can just revisit them, you can re-understand them, right? Just have a short revision. And yeah, because permanently remembering it, uh, that does not happen usually, right?
Hmm.
You're bound to forget. So basically what I mean is that you can write formulas. The best thing would be to practice, but again, maybe you will just practice it once a week, twice a week until the exam. But then again, what after that? So if these things are going to be of use for you, um, then you'll stay in practice. So, for example, you might have come across these things first. Maybe I don't know. I don't know if some school boards teach it in 11th and 12th, and then maybe in undergrads, if some of you had maths, you might have come across this. But then, like, I also studied this thing in my second year, and then it's been 5 years now. So after that, I'm reading
After
this.
12th, I'm not studying maths. That's why it
Yeah,
becomes more
yeah,
difficult.
yeah. So, but then you faintly remember something. At least all of you knew what probability is. So
Hmm.
you're starting from there. You will have to revisit some things of probability, of course, right?
Hmm.
But you can build on it. So we just want that whatever. So for the next roughly 1 month more for this course, right? So until then, you stay in practice, so that even if after the course ends, you lose touch for a year or two, whenever next you are going to use it, at least the base is
Hmm.
strong. So you can quickly revise and you'll get the hang back.
Hmm.
Yeah.
Sure.
Yeah. All right. Thank you for asking.
No, thanks.
Yeah. Okay. So, okay, we have a lot of people join in now. So we'll start the session. So, like I was saying, um, I have tried. So today we are not going in depth into everything that was taught. I'm quickly summarizing everything, because now we have two additional things to do. One is we'll solve some questions from the topic of this week itself, and we'll also take a look at the solution from the last week's assignment. So we want to have sufficient time for that and not rush things and at the end. All right. But of course, if you have any questions anywhere, just unmute yourselves and ask, or you can do it you can write in the chat box. You've just joined the course. You mean the assignments also? Yeah. Okay. So as far as the assignment and the grading is considered, I think best some number of assignments out of 8 are going to be taken if you are interested in registering for the exam also and to get the certificate. So since 3 assignments have been graded already, so you can start off with the 4th assignment. But I'm not sure if 5 out of 8 would be enough for the certificate. But if you're interested in just reading through, like attending the lectures, and also if you would like to see these problem solving sessions, so if you go to the course page itself, you'll have all the videos there with you, roughly 20, 30, 40 minutes maximum videos. You can watch them at your own time, and the assignments are anyways available. You can take a look for your own practice, and that's there. But for the exam and certificate, you'll have to check with the NPTEL. I think in the course introduction itself, they've mentioned how many assignments are required. I think it's 6 out of 8. Can somebody confirm if you remember that number?
Yes, ma'am, 6.
Yeah, 6, right? So, yeah. Anything else?
Yeah, last time we discussed about like the electronic that calculator will be available, or we have to
Right,
carry
right,
the
right. So, sorry, I confirmed. So, yeah, the online calculator will be available to you.
Okay, thank
Yeah.
you so much.
So, that will be there. So, you can try to practice on any of the online calculators. Yeah, so that just you are, you know how to go about it. And for those of you who might have joined late, so last week we had discussed about some questions from assignment 1 and 2 that had slightly confusing solutions, or the topic was a little different than what was taught in the lectures. So the instructor and the team, they're looking into it, if they need to be regraded, or how does that need to go about. So you'll be informed of whatever decision is taken. All right. And so yeah, so let's start with today's session. Just give me a second. Okay. All right. So I hope you've all been able to access, if required, you can access the YouTube link for the previous recording of these live sessions, and the Google Drive, which has these presentations, right? And any Excel sheet that we are using in calculations, if at all. Okay. So this week start. Yeah.
Can you please paste the links in chat box?
I will.
That
Can I paste it at the end of today's meeting?
Yes, sure.
Yeah. All right. Okay. So,
Or or you can mail on the
sorry, can you say that again?
or you can mail on the that we have a group, no?
Yeah.
Mail
So,
group.
these things, so the links and all, they're anyway available to you in the course announcement itself. But let me just paste it right away. So, yeah, Zoom link anyway you've all joined, and the YouTube and the Google Drive link is here. Okay. All right. Okay. So, yeah. Okay. So this week's topic, we just start off by talking about factorial. Okay. So there are two notations of factorial. It's either the exclamation mark, or an older notation is this, like an L-shaped. So what this means is that you'll multiply n into n minus 1 into n minus 2, sorry, all the way until 2 and then 1. Sorry for the, yeah. So this is how it's going to be. This is factorial. Okay. So where does this, where are we going to use this? So we'll see in terms of permutations and combinations. Now, permutations, when when the arrangement and the number of arrangements is what you're interested in. So when you're talking about the order of things, when you say 1, 2, 3, 4 is different from 4, 3, 2, 1, different from 2, 3, 4, 1, and so on, then permutation comes. But actually, so before that, just a clarification, right? So you have these, let's say you have the 4 alphabets, right? Now, how many words can you make with these alphabets? If I'm asking you the simple question, these words don't have to have a meaning, but just the simple thing, how many 4-letter words can you make out of it? So the first thing that we're
4
talking,
factorial.
sorry, yeah, right.
4
So
factorial.
so when we are saying 4 factorial, we are basically doing 4 into 3 into 2 into 1. Now, before we are going into this arrangement, the assumptions is that we are talking about 4-letter words, right? We're not saying a single letter word and a double letter word and a triple letter word or a 4-letter word. Then the number of these possibilities is going to increase, right? So here the length of our selection, that is constant. That's the first thing, right? Because right now we are doing relatively simpler questions, but if you take any handbook which has like complicated permutation and combination questions, so they can really confuse you, right? So the simple assumption for the basic permutation is the size of that selection is constant. If you are talking about multiple sizes in this case, then you will do a permutation at each step. So I'll explain what that is. And the second thing is you are not repeating anything, not repeating the elements, right? So when we are saying you want to make a 4-letter word, you're not a word like a. That's not what you're making. You just have a single A available, a single B, a single C, and a single D available, right? So now once that is available with you, then you have 2 options. Whether you are interested in the order, right? The order is important, right? Or just like the grouping. Okay. So now just a simple example from this. So you have 4 alphabets, and now how many 3-letter words can you make? Right? So in this case, when you're saying 3-letter words, first thing, 4-letter or whatever, in this case, like n-letter word only, and where n is fixed. Right? So here it's 3-letter word, and we're saying you're not repeating. You just have these. So how many can you make? So since we're just just explaining right now, so you can have A in the first position, then like this, and then A and C and D, D and C. So you obviously you have a lot of options, right? So now, how did we get into this? So you have 3 positions are there to fill. In the first position, you can have any of the 4 letters, right? In the next one, you can have any of the remaining 3. And in the last one, you can have any of the remaining 2. So this is like your basic 4 into 3 into 2, which is equal to 24. So 24 words you can make. Now, let's try and understand this in terms of permutations. So this is represented as, you know what, how it's written.
Ma'am, 4p3.
4p3, right? And so it's basically 4 factorial divided by 4 minus 3 factorial, right? So you will have 4 factorial divided by 1 factorial. 1 factorial is 1. So it's 4 factorial. So 4 into 3 into 2 into 1, which is this number itself, right? So that's clear. Just a very similar example here. So take a look at question 1. So you have 10 people and you want to make a committee of 3 people such that one of them is going to be the president, one of them is going to be the vice president, and one is going to be the chairperson. So again, in this case, somebody being the president, vice president, and chairperson versus these 3 in a different for a different post, they're different outputs, right? They're different ordering. So here in this case, when such an information is used, the order is important. So in this case, again, what is it going to be?
10p3.
10p3, right? You can solve this. So can one of you quickly solve this? I do have the answer with me, but let's just check. So it's 10 factor. Yeah.
720.
720.
720.
720. I hope all of you have got 720 as the answer, right? Because it's 10p3. Order is important. So yeah. So it's 10, like this number factorial divided by n minus r. So 7 factorial. Right? So basically it's 10 into 9 into 8. Right? So that's 72 into 10, 720. Okay. Now, so now I'm giving you an extra information in this case that out of those 10 people, 4 of them are proficient in public speaking and 6 of them are not so proficient. So now you want to make a committee of, again, 3 people, one of them president, vice president, chairperson. Now you tell me, what is the number of, so if you have this additional information, is this number going to change? If so, what? If not, why not?
The number is not going to change because they have not asked ki those people should be proficient or not.
Yeah, true. Good point. So that is absolutely the correct answer. So the answer remains the same. And now there's just one more way in which we can calculate this, just a complicated way, but it might just clarify a few things. So now let's say, so we are talking about 4 people proficient, 6 not proficient. So now what may happen is you can say that maybe all the 4, out of 4, all the 3 are chosen. And out of the remaining 6, nobody is chosen. This is one option, right? Like multiplication, right? Or you can have out of the 4, 2 are chosen, and out of the 6, 1 is chosen. Or what you can have, out of the 4, there's 1 chosen, out of the remaining 6, 2. Or you can have none of the 4 are chosen, but out of the 6, all the 3 are from those other 6 people, right? So you can define it like this, right? So if I do it like this, which is a slightly more complicated way, do you think I should still get the same answer? Now I'm just trying to confuse you with this. Okay?
We'll get the same answer.
We should get the same answer, right? Can you solve this? Somebody along with me? These 4 numbers. So this and like these 4 things. So what does this give you? It should be 24, I guess, right?
Yes, ma'am.
One.
It's 24.
Yeah?
Yeah, it's 24.
24. And what is this one then? I had it solved somewhere, but I did not keep that notebook along with me. Hence, I'm asking all of you.
Ma'am, actually, the first one is 24. Sorry. First part, I need to solve the second part.
So second part is 6p0. So 6 factorial by 6 factorial, right? It's fine. right? 6 factorial divided by 6 minus 0 factorial. So that's 1.
Second is 72.
70 what?
2.
2. Okay. And this one? So this is 4 factorial by 3 factorial into 6 factorial by 4 factorial. 6 into 5.
120.
Yeah. Yeah. Okay. And this one is again going to be 6. This is also 120, is it?
It's 120.
Yeah. Okay. So if I add these 4 numbers, I don't get 720, do I? So did we do something wrong?
The first is not 24. It should be 4 only.
Last one should be 480. If I'm
Okay.
wrong.
1 second. So 4 factorial by 4 minus
Acha, nahi, no,
3
fine.
factorial. So that's 1 factorial. That's 4 into 3 into 2. No, it should be 24. That's fine. I think these numbers, they are fine. These calculations is fine. But still we are not getting 720. So what can any of you tell me? There's one small bit we are missing here. Okay. So now when we are saying 4p3, right? So these 3 people, 1 president, 1 vice president, and 1 chairperson. That's okay. Here also, all 3 of them, president, vice president, chairperson. That's fine. But now when we are saying 2 and 1, should it be these 2 and this one? Or should it be this separate and these 2? Or should it be this one separate and these 2 in this group of 3? Group of, like when we are saying 2 and 1, is this one separate president? Is this one vice president? Or is this one chairperson? Right? So there are 3 ways of making this distribution, 1 versus 2. Yeah. Is this making sense?
Getting complicated.
It is getting complicated. So exactly. So this is the simpler thing. This you have understood. So this extra information, I'm just trying to, so just to give you a better idea of how complicated permutation can be, right? So when we are saying maybe 2 people are of the one which is proficient and 1 is from the non-proficient group, who is this 1 person? 1 is chosen. So when we are saying the group of 4 and 6, we are saying, okay, 1 is chosen from that 6. But for what post? Is it the president? Is it the vice president or the chairperson? So there are 3 options of doing this thing, this combination, this permutation. Likewise, for here also, there are 3 options. So what you need to do is you need to multiply this 72 with 3 and you need to multiply this 120 also with 3. So now you have 24 plus this is 216 and this is 360 and this is 120. So now if you add this up, then you're going to get 720 as the answer. Okay. So this thing is not important to calculate the actual permutation because this you have seen you can calculate from here. But so this is like, this becomes your denominator whenever, as we'll see in terms of probability, it's like all the possible options. Now in the numerator will come some particular case that what was the possibility that the president was from this group and the other 2 were from the other groups and things like that. So in that case, something like this is what you're going to use. So you're also considering the 2 groups of proficiency in public speaking, and you're also considering the 3 posts, president, vice president, and chairperson. Okay. Now, same example, but now we are just talking about make a committee, right? So now in this case, simpler thing, 10 people make a committee of 3. What are the combinations? So here we are just saying that which 3 people are going to be chosen. So what are the options? What are we going to write in here? Anybody?
NP3.
10C3. The order is not important. We just are interested in which 3 people are going to be chosen. Right? So that's 10 divided by 3 factorial and 7 factorial. So 10 into 9 into 8, 3 into 2, 3 and 4. So that's going to be 120. Yeah. Yeah. Right? And now, again, let's say we have this additional information and we would like to get the same number with this additional information. So can you tell me, the way we proceeded in the last question, what are the 4 possibilities we have? So we have all the 3 being chosen from the proficient group and none being chosen from the other group of 6. Right? Now, here in this case, do we multiply it by 3? Do we not multiply it by 3? What are these values? Can anybody tell me what makes sense in this case?
Should not be multiplied by
Is not
3
important.
because order is not important.
Correct. Right? We're just making a committee. There's no question of 3 coming up, right? We don't have those posts here. So we are not going to multiply by 3. It's just these 3 numbers and we're just going to, these 4 numbers, and we're just going to add this up. Right? So you can calculate, but you will see that this is also adding up to 120. Okay. So again, this was complicated, but just wanted to give you an idea so that it's, slightly something hits and it just gets better. Okay. So permutation and combination, that's there. And then we talk about the types of events. So these 2 names, the first 2 especially, came very often in many of the lectures: exclusive events and independent events. And last time one of you also asked about exhaustive events. So when we are talking about mutually exclusive events, it means that when you're defining events, right, you're defining each of the possible elements in these events, and you're checking if there are any common elements or not. If there are no common elements, then they're exclusive of each other. Nothing is common, right? When you're talking about independent events, so if the event is not independent, it means it's dependent. Hence, I've written it in bracket like this. So this means that does one depend on the other? If you change one, does the other one also change? Right? And exhaustive events means it's 2 or 3 or 4 events that together make up your whole sample space. They don't themselves need to be, there's no rule about them being independent or exclusive. They may or may not. But if all of them together are making up your whole sample space, then they will be mutually exhaustive. That means when you're adding them up, when you're finding the union, not adding just directly, but when you're finding the union of all these events, you get the probability 1. That's what exhaustive events mean. So I have a few examples. A simple a dice is rolled twice. So you can have these can be just I've defined random events, right? Event is that you're getting a sum of 12. Event is you're getting a sum of 2. Event is you're getting a sum which is greater than 7. Sum which is between 8 and 12. That between 8 and 12, excluding these numbers, means 9, 10, or 11. This is 8, 9, 10, 11, 12. So maybe more than one answer can be correct. So can you tell me which of these 5 events, can you tell me 2 events which are mutually exclusive of each other? That means there are no common elements in it. Multiple answers are correct in this. So which 2 events will you say that they are mutually exclusive?
A and B.
A and B, simple, right? So A and B mutually exclusive. A and C is also, A and C is not mutually exclusive, right? A and D is, right? But A and E is not, right? So something like that. So you get the idea, right? Mutually exclusive. And so changing one changes the other. So let's say now I should actually write one more. So let's say, so sum greater than 20 and right. So when one is even, so let's say, okay, I think I need a better example for this, for independent events. I'll think about it and tell you. But you get the gist, right? When they're defined in such a way that when you change one, the other can change. The elements which are making up that event, they can change.
Some cards, playing cards. From
Uh,
there we can
When
jump
one
out.
card is drawn, it can't be placed back in the deck. Independent.
Yeah, that is also an example. Correct. Right, good. So yeah, so correct. And then you can have these, so yeah. So can you tell me, is there any example here which makes up exhaustive events? Because you know the total sample sizes, you have 36 options, right? So do you think all of this or some of this together, they make the exhaustive group? What's which of them? Like, so exhaustive means they make up the whole sample size. So here it's sum of 12 only, so it is only 6,6. Sum of 2, we know it's only 1,1. A sum greater than 7, so you can have sum is 8, sum is 9, 10, 11, 12. So basically C and E are actually the same thing, right? So yeah, so even when you add all of this up, you don't get an exhaustive set. So you don't get the whole sample size. So these events are not exhaustive. All right, so this is just types of events that you will come across when talking about probability. Then, so this formula is something you need to know, right? And this is coming from the Venn diagram, right? So simple example, this is event A, this is event B. This part means both A and B, right? So you can write it as A intersect B, and the whole area, right? The whole of it is A or B, which is A union B, right? So now if you add this and you add the probability of this, you are counting this middle probability twice. Therefore, you subtract it and you get the union. So that's the formula. This is a universal formula, irrespective of whether you're talking about independent events or exhaustive events or exclusive events. But when you do talk about independent or exhaustive events, you get two sub sort of like corollaries of this formula, right? So for independent events, what happens is you define that the probability of this thing happening is these two probabilities happening, like this multiplication sign comes up. Right? For independent events, the intersection is nothing but the product of the two probabilities. So now when this is the this is the formula, then you can plug this in. So this thing becomes union is probability of A plus probability of B minus the product of the probabilities. This formula we are actually going to use a little later in a couple of slides down. Right? So this is there. And then for exclusive events, so we talked about, right? So exclusive means there are no common elements present. So this intersection does not exist actually, right? So for exclusive events, it's like this. So if you want to find the intersection, you don't find an intersection. There are no common elements, so it's 0. So this thing actually becomes 0. So union is nothing but just the sum. The third term goes away. All right. This is there. And then we talk about conditional probability. This is sort of where
Can we go back to the previous slide once?
Yeah. Right? So independent and exclusive. The events are defined as independent when so event A is not affecting B. So the intersect is just the product of the two probabilities. And that's what you simply plug into the formula. And for exclusive events, this intersect is 0. So it's the union is only the sum of these two probabilities. Yeah, anything else?
No.
All right. So, okay. So then when we talked about independent and dependent, so dependent events, they're not really said like this. So by default, you consider one event is dependent on the other, right? So when that does happen, you say that the probability of B happening. So now, so again, so let's say this is A and B. Now, maybe the probability of, so let's define in terms of that dice roll. So A is just even number. So we're yeah, so even, and we have as a single one dice. Okay, so event A is even number and simple. Event B is the n has to be greater than equal to 4. All right. So now I am also, so this is generally a rectangle is used to denote the like the universal set. Anything, any element which is not in A and B, but it can be in the sample space, that's defined with that's defined in this rectangular section. So what all numbers do I fill in A and B in this intersect and outside? So where would 1 go? So the option is this rectangle, this part of the circle, this intersect, or this part of the circle. So where would 1 go?
Outside.
Outside, right? 1. 2.
Within the circle.
Sorry?
A.
Within the circle.
Only A.
Only A.
A.
3.
Outside.
A outside.
Good. 4.
Or
The
B.
common space.
intersection.
Common.
Intersection.
Yeah. Okay. 5.
5B.
Outside.
And no, 5 will be in B, greater than. And 6.
Intersection.
Intersect. Yeah. All right. Good. So now let's say if I just write what is the probability of A happening. Forget whether B is there or not, right? When you're just saying probability of A happening, so you don't even need to see the Venn diagram. You know, even numbers, 2, 4, 6, 3 options, 3 out of 6, that's 1/2, right? This is simple. If I just write probability of B happening greater than equal to 4, so just the way we have defined it, this is also 3 by 6. So you get 1 by 2. That's okay. Now if I say, so what does this thing mean? This means that A has already occurred. Now what is the probability that B has occurred? B has also occurred, right? So this means that this circle has occurred. That means you now have numbers 2, 4, or 6. Now what is the probability that B also occurs in that? So initially your sample size was 1, 2, 3, 4, 5, 6. There were 6, out of which these 3 could give you the answer. But now your sample size has reduced. When something has occurred, some event has occurred, so only something is remaining out of that sample space. Now A has occurred, so that means only you have 3 options, 2, 4, and 6. Right? Now out of that we are saying, out of 2, 4, and 6, what is the probability that you will get a number greater than 4, greater than equal to 4? So now you only have these 2 options.
2 by.
So it's 2 by 3 now. So this is your new probability. Now we can also get this by using this formula. So what is the probability A intersect B? It is this thing. So what would I write in the numerator?
2.
So it's probability, right? So probability will always be of a fraction form, even though that denominator is going to get cut, but still, right? So it's probability of A intersect B. So A intersect B means an even number which is also greater than equal to 4. So it's 4 and 6, which means 2 out of 6 options. Because for this thing, your sample space is same as what was initially. And then probability of A happening, so A is even number. So 2, 4, 6. So this is 3 by 6, right? So now I also get 2 by 3 in this way.
Last one, done.
Sorry? Anything? Nothing? Okay. Right? Now let's try the other option. So now we're talking about, so this means that B has occurred and we want to find the probability of A happening once B has occurred. That means now, so initially, the probability of A happening just on its own was 3 by 6. But now B has occurred. So 4, 5, and 6 are there. So this is not a really good example because it will again give us 2 by 3. Yeah. But you get the gist, right? If you want, we can change the example. But this is how it is, right? You're changing the sample size now. The sample space is now different. It's reduced. But so has your possible outcomes, right? Okay. And now when we were talking about independent events, so now in case of independent events, what happens is the intersect. So the by definition, independent events means one does not affect the other. So when B is happening, irrespective of whether A has happened or not, the probability of B should stay the same, right? So this is given by this formula also. This is this formula, but we know for independent events, the intersect is nothing but the product of the two probabilities. So then you are able to cut this. So you get the probability of B. So probability of B given A has happened, or the probability of B just like that. It's the same thing. And same is the case with probability of A given B is the same as probability of A happening. So you're not concerned whether some event has happened or not. Okay, so this is how conditional probability works. And now if you take a look at these two formulas, so you can see that the numerator in both of them is the same, right? So if you just cross multiply, so you get B given A multiplied by probability of A and A given B multiplied by probability of B. So you get this equation, right? And you can just rewrite it in whatever terms. So this is what formulates your Bayes theorem. And you can have some examples coming up from this. Another added level of complication into this is Okay, I'll just come into it. Yeah, so this one. I'll come back to those slides a little later. So then you can have these. So until now we were talking about just independent and exclusive or exhaustive events. So now let's say so this is how we had defined A and this was B, right? Now I can say that if I'm only drawing B, so this is B and the rest of the shaded part, this is B complement, right? Because what does complement mean? Sorry. So this means that the probability of B complement happening. So if you forget about A, if you're just talking about the event B, so either the event B will happen or the event B will not happen. So the fact that B is not happening, it means everything except B. Anything except B has happened. So that is set as the complement. And that's nothing but 1 minus the probability of B. Because this happening or rest of it happening, it should amount to 1, right? Probability, the total, something has to happen, right? So that is going to give you the probability of 1. So now what I can do here is, now you see this part of A, and if you see this part of A, right? So this part of A can be defined as A and B. This is how we define it, right? And this part of A can be defined as A and B complement, right? Because if you see, this thing is falling here in the green shaded area, right? So, yeah, right? So the probability of A, the total thing, is a sum of A happening with B complement and A happening with B, right? So this is what I've written here. And then, so if you're talking about independent events, then this can be split as written as this, right? So now you're just making some, so I've brought it to the left side and you can take PA common. So this becomes 1 minus PB, and we just saw what 1 minus probability of B is. This is probability of B complement. And now what does this notation mean? Whenever you're talking about A and B complement, you here also you're getting this thing that A multiplied by probability of B complement, right? So we defined, so this we defined here. A and B are independent, therefore you are multiplying. Here also you get this. This means A and B complement are also independent. And you can, instead of splitting this, instead of writing BA, you can also do this with respect to B, right? So probability of B is probability of B with A and probability of B with A complement. So then you will also get that all the 4 combinations, they are all independent of each other. A and B complement, B and A complement and B complement, right? So that's there. And then we also have, so now events. So now when you're talking about distributions, so most of the examples that we saw until now, they're discrete, right? It's element A, element 1, element 2, so 1, 1 is one option, 1, 2 is another option. So you have these distinct events, right? So basically what you have is, you have on the x-axis, you have the possible events or like the elements of in each event. And here you have defined the probability of each of them. So in case of, like for a dice, for example, single roll of dice, you have 1, 2, 3, 4, 5, 6. And let's say it is a biased dice. So what it means is, maybe one of the sides is heavier, so that it's a chance that, one or some numbers is going to come more frequently. So you can have something like this, right? This is your distribution, maybe, right? That maybe the probability of 2 happening is slightly higher, or it's going to be all the same if you have like the exact, if it's an unbiased dice, you'll have all these things as same, and that's going to be 1 by 6. So this is how you define a probability mass function. X-axis, you have that element, and on y-axis, or like the event, and on the y-axis, you have the probability of it happening. But now in case of continuous variables, probability of x being between 1 and 2. So it can be any number being less than 1, greater than 2. And if you're defining it like this, so then, so the notation that is used is you have x here, but here you actually have fx, a function of x, and which can, so let's say this is minus infinity to plus infinity, and it's some, so something like this. Yep. Now the probability is actually the integration. Now what integration basically means is that, let's say you have this a and b here. So you basically want to find the area. Now this area is actually equal to your probability of x being greater than equal to a, less than equal to b. Okay. Please note the different y-axis in these two examples. In case of probability mass function, the y-axis is directly your probability. So which is why when you have a particular value of x, you have a corresponding value of probability, so you can just use it directly, right? Probability x for a particular value, for that discrete value, it's generally a non-zero number, unless you've actually said that that event is impossible. So let's say a dice has, let's say like in this case, it has two faces which have 2 written on it, and there's no face with a 3. So that's separate, that, but you have explicitly mentioned that for this element it's not there. Otherwise these values are non-zero. But in case of probability density function, since you're taking an integration, so let's say if I want to find the probability of x being 100, so 100 is just the single line, right? The integration of a line is 0. There's no area covered in that line. If it's between 100 and 101, this, you have an area then, right? So for a continuous random distribution, the probability at a particular value is 0. Because see, this whole sum is actually equal to 1, right? So integration from minus infinity to plus infinity of this thing, that is equal to 1, right? So at a particular value, there's no value. It's not any number, right? So this is the difference between defining probability for a discrete distribution or a continuous distribution. And this was also used, this is very similar to what you've already seen initially when we were talking about mean of a thing. So it's basically the weighted average, right? Or in terms of so it's this thing, right? So again, in case of a dice roll, simple example, right? The expectation. So since each of the numbers, like we discussed, they can occur at a similar probability, 1 by 6 for each of them. So the average is 3.5, right? So if you multiply 1 with its probability, and then 2 with its probability, and so on, right? 6 with the probability, you will get 3.5. If these numbers are actually different, then of course, in that case, it becomes like a weighted average, weighted mean. And it's going to be the integration formula, right? So fx, so x times fx dx, and integration from whatever to whatever you're talking about. Yeah, so basically it's, so this part is your probability, right? And this is the expectation of x, like we did here, probability multiplied by the value. Okay. Okay, so that is what I had for the summary. We can quickly take a look at some, I think I just have 5-6 questions for this part. Then we can also discuss the last week's assignment. Okay, so all right. So now this, it'll be good if you solve it along with me, right? So the sample space is A, B, C, D, E. What is the probability of the first event? Event A described as A, and the event 2 is the element G.
Answer A.
Yes,
Answer A.
answer A, right? So this is 1 by 5, which is 0.2, and G is not in your sample, so that can never happen, right? So option A. Okay, simple. So X is a discrete random variable. The probability distribution is given. This is the probability mass distribution. So what is the expected value of X, right? So how are we going to solve this? So it's minus 4 into 0.25 plus minus 1 into 0.1 plus 4 into 0.5 plus 6 into 0.15. And of course, just like a sanity check, you should always see that this should add up to 1, right? So 25, 15, 40, 90, 100. Yeah, this is adding to 1. So then you can add this is basically minus 1 plus,
1.8.
okay, you solved it. Yeah, so it should come to 1.8. Good. Yeah, so you can simple calculations. Okay. Next question. If A and B are two independent events, which of the following statements is correct with respect to probability?
All.
All of them. So independent events, the first one is obviously correct. And we also saw how we can derive the next two, right? And another one which is going to be correct in this case is this is also going to be correct. So all of the above. Okay. Oh, this we already saw. Yeah, similar to this. In how many ways can you choose 4 students in a class of 10? So the keyword here is choose, right? So combination, choosing, yeah, since you don't have any other extra information given. So this is 10C4, which is 10 factorial by 6 factorial.
210.
Yeah, okay. I'll just,
210.
I think so. It's 210. Let's just check. So this will cancel 4 into 3 into 2. And this is going to cancel. This is 6. So yeah, it's 420, I think. Is it? Can you confirm?
210.
But it is
3
2.
and 9 cancel. It's 3.
It's with the 9.
Oh, sorry. Yeah. Yeah. 210. Sorry. Okay, good. 420 is not even the option. Yeah, okay. It's 210. Good. If A and B are two independent events, then which of the following statements is correct?
None.
None? Yeah, good. Right? So this is only when the event is not present in your sample space, and this does not happen. If it was the opposite, P, B, then that would have been fine, but it is none of the above. Okay. Again, if A and B are independent and probability of A and B are given, what is probability of A complement?
0.1, sir.
Yeah.
0.1, sir.
Okay, good, very quick. So I'll just solve this. So probability of A complement, B complement, since A and B are independent, so we saw all the other combinations are also independent. So this becomes this thing. And we know what complement means. 1 minus probability of A multiplied by 1 minus probability of B, right? So this is 1 minus 0.3 and this is 1 minus 0.8, 0.7, 0.2. So this is 0.14. All right. Oh, that's it. Okay, that was quick. Okay, so before we go to the last week's assignment, anything else you would like to discuss about this week? The topics that we saw right now? Nothing? Good. All right. Okay. So I hope you can see the screen. Okay. So, yeah. So to determine the protein concentration in a sample, so you would have seen actually that a lot of these questions have some concepts that come from bio, right? So don't get a lot confused by it if you're not familiar with these terms, right? So basically, you have, this is X, this is Y. You want to find the covariance between the two variables, approximate the value to 2 decimal places, right? So don't get confused by that, right? So yeah, it's the formula used. So mean of X, mean of Y, and covariance here it's yeah. So any confusion about this question, because I think it's relatively straightforward.
Oh, no.
No, what happened?
I mean, yeah, it's no confusion in this.
Yeah, okay. Yeah, all right. So yeah. So yeah, simple. Just use the formula of covariance and that's it. Okay. Next question. Hemoglobin demonstrates cooperativity and oxygen binding, which makes it an efficient transporter of oxygen. An oxygen binding curve was constructed using the saturation of hemoglobin versus the how much oxygen in mm per Hg was binding. So now here you want to find the correlation coefficient, right? So again, so for correlation coefficient, you have this formula, right? The covariance divided by the standard deviation. And if you rearrange it a little bit, you would have this term n-1 and n coming up. So you can actually see and rearrange this. But see, the exact derivation is up to you. What values you want to calculate. You can, again, like it was done in the previous question, x minus x bar, y minus y bar. You can also use that, right? So that's up to you which calculations you want to do. But again, same formula, the straightforward formula was used. So I hope here again, like the formulas of standard deviation, everything, n-1 has been taken care of, right? So there's no confusion in this, right? Yeah.
Yes.
Okay. All right. Good. Which of the following statements on correlation coefficient is false? So, right. So it's used to assess the strength of association between two variables. That is correct. And correlation coefficient independent of standard deviation, that's false, right? Because the denominator is the standard deviation. And correlation coefficient of two variables in a non-linear relationship is 0. This is possible. In a non-linear relationship, you may get actually a correlation of some number, but 0 is also possible. And positive association will have a positive value, right? So
Yeah, so like in case 0, yeah, in case the
Yeah.
number C is also incorrect, right?
So it can be 0, right? I understand it's not always 0, but it can be 0. So since only one option is correct, so this is the obvious correct choice. But this is like a slightly confusing thing, but I wouldn't go too much into it because this is an obvious option that's false here, right?
Yeah.
Yeah. Because this is how, like, at least for questions where you have one correct option only, this ambiguity will should not make a difference. Okay. So number of cells in a culture, it increases according to the exponential model to determine the growth of this. This is a growth curve experiment was carried out. So you have at different time points, the absorbance values was taken. So which data best fits the which equation best fits the data, right? So you have to go into the linear regression part. So how it's done, you have x, y, you're calculating all these values. And so you remember this slightly lengthy derivation, but so basically this is the linear model you are using, and you would like to find the values of b and a. They are your unknowns here. So b is defined in terms of the correlation coefficient, right? So some formula, you can check the derivation again, but basically you're finding using, you're calculating b, and then that value of b you are plugging it into y minus bx upon n. And yeah, so here yeah, so it's n here because it's summation. It has to be mean by bar, so that's y, sum y by n, and this is sum of x by n. Calculating, so you get both a and b. So the closest was 0.006 and 0.3. Okay. Okay, then the next question, a student is yeah.
Hello, madam. Will you have time in the exam, ma'am? For one question, it will take I think so 5 minutes.
Yes, that is true. But
Any shortcut to do this, ma'am? Anything?
no, nothing.
Okay,
The only thing is, see, the only thing is you will have the calculators, right?
Even if we miss one number, we'll get a wrong answer.
Yes, so you have to be careful. So that is true. So instead of hurrying, it's better. So again, you can divide your time, right? It's always, since the number of marks per question is going to be the same, you solve the questions first which you're sure are going to take lesser time, right? And then you come on to more complicated questions, right? These tricks you'll have to use because there's no shortcut.
No, you don't use the desmos.com graph.
You can't use it in the exam.
That we can't use, madam?
No, that was only for your practice. Yeah.
Okay.
Graphs, I think I mentioned it last time also, but yeah, graphs not for the exam. They were just to give you an idea, to just practice and to get a feel of if you have x square term, x cube term, exponential, how does the graph increase or decrease. That's it. I can give you one trick, but again, at your own risk. So you can see here that the options are somewhat different, right? It's not like 0.6 and 0.65. So you can try fitting in 1 or 2 points in each of these and see which of them fits best, right? So this is x, this is y. So you have to be correct in seeing that. So against time, generally, this thing becomes your x here, right? So you can try plugging in and seeing which one fits best. But again, that's not the right way, but that might take lesser time.
Thank you, ma'am.
Yeah. Okay. Then a student is curious about the impact dedicated study hours have on their academic performance. Number of hours the student spends each day is given below in terms of the test score. This looks wonderful. Okay. So the more you study, the better your test score is. So consider this relationship. If the student were to spend 3 hours per day, what score would you predict? So again, here we are assuming a linear regression, same as before, right? Same formula you're using. Yeah.
Ma'am, here actually y equal to ax plus b, last answer last.
Mm-hmm.
Yeah.
It is to 16.4 and b a 2.4. And how they minus here, ma'am?
Exactly.
Ah.
Even I had that same
I
thing.
got plus and I got 52 answer I wrote. So
Oh,
minus.
okay. Wait.
Yeah, because the linear equation says y equals to bx plus a. Neither the
Yeah.
b minus, neither the a is in a negative.
No, negative. I solved and I got it 52 and I put
Okay.
that
Same here. I got
Okay,
52.
okay.
Yeah,
All
I
right.
made it wrong.
Okay, so actually that should make sense.
Just want to know how they took minus sign, ma'am, because
Absolutely, yeah. So even I was curious about like how
yeah.
why minus.
seeing the solution, I was
So-
thinking how they took it as minus
Because
2.5.
neither the A is negative, neither the B is
So
B is
negative.
then
positive.
in that case it should not be
Yeah.
minus,
That's
right?
why, yeah.
Yeah, absolutely. Because the equation itself says y equals to bx plus a.
And
The
it
B
is not
you have
telling us
3.4 into
integrating
3
or
plus
Right, right.
2.4.
Right. So then in this case it should be positive.
Yeah, and the answer
Yeah,
is
the
52.
answer is
52
52 in that
answer.
case. Okay.
51.6 on the nearest
50.1,
figure is
yeah,
52.
51.6, so I
Alright.
approximated it to 52.
Okay. So question
Approximated your answer
5.
to nearest integer they had
Yeah,
given.
yeah. That makes sense. So question 5, here you have 16.4 plus 2.4, right? So okay, I'll convey this. This should be corrected. Okay. Thanks for pointing it out. Okay. All right, next question. So some molecule, it's known to be associated with mitochondrial stress in cancer cells. It has a role in cell death signaling. To find out its role as a candidate for a therapy, the concentration of this molecule in the membrane and the oxidative stress that's given to the cells, it's recorded below. So what is the expected change in the level of oxidative stress per in terms of in this increase in okay, yeah. So you want to quantify this with an increase in this, right? Now simple, if you make if you're trying to see A and B in this case, so it's AX plus B, right? So in that terms, so you actually, the thing is you would like to calculate just B, right? You as such don't need to calculate A in this case, because what the argument here is, B is that rate of change, right? So per one, because if I can just write this
Yeah,
here.
you're correct. Just need to
Yeah.
calculate the slope.
Yeah, right. So this is second. So this is X, this is Y, and so this is basically your A, and this slope is B, right? Sorry. This is A, this is B. Right? So you're writing Y is equal to AX plus B. So A is actually giving you its units are going to be Y by X. Right? So you can have this in terms of just 1 units of X. So that's basically what A is giving you. That's the funda of this thing. I'm not able to explain it correctly, but you get the gist, right? So per anything, so that becomes, so you just need to calculate B in this case, which is 0.47. So that's your answer. Did any of you have a question?
No, I'm good.
Okay, all right. Okay, so during a enzyme kinetics experiment, this was recorded. So velocity of 3 plus minus something minutes correspond to a substrate, some concentration. What would be the estimated enzyme velocity if the substrate concentration is this? Now here, the important part is so what this notation is implying here is mean plus minus standard deviation, right? So so once you have that, so you have the mean X bar and Y bar, you have the standard deviation sigma of X and sigma of Y, and this formula is actually something that you can derive. So were all of you able to derive this, or should I derive this for you? Because so there were 2 formulas. So one is in like the formula of A and B itself, right? When you have the formula of, you plug the formula of B and you also write the formula of A, like both in that equation. So this is what you're going to get.
Yeah, right. Whenever the correlation coefficient is mentioned, so we just need to calculate the slope as r into standard deviation of x by standard deviation of y, right?
Yeah.
And then later on, when we have the slope, then we can plug in with that same linear
Right.
equation.
Right. So with this thing, when you
Can you explain this equation?
okay, I think I'll have to derive this then. So let me open the last week's equation. That will make it simpler. Right, so this is what the equation was, right? Let me copy this here. Okay. So we have y bar is equal to a plus b. Now this value of b we can write here. This becomes y bar is equal to a plus b. Sorry, we'll write rho sigma y by sigma x into x bar, right? Now this is there, but actually what other than that we can do is, so this is going to be valid for this also. A plus b xi, and we'll see y minus sigma x. Oh no, it's y sigma x, right? So we take this value of a and I think it will be better if I write it this way, is equal to y bar minus b x bar plus b xi, right? So if you just, so we are using the same formula for the y bar and x bar also, and xi yi also, right? Xi yi being any two values, so we would plug in I and we would get the value of y in this case. So what we can do is we can take minus b common. This would give us x bar minus xi yi. So we can take this here. So b is equal to yi minus y bar upon, and the minus sign should go, yeah, xi minus x bar, right? And then we know what b value is, right? This is sigma, rho sigma y by sigma x, that is equal to yi minus y bar upon xi minus x bar. Yeah, I hope this is the same thing which was written in the question. Yeah, this thing. It's just the opposite. This is sigma. Did I do something wrong in 1 by sigma or something like that?
Now regression line y x on y.
Sorry?
This is x on y, and there is another one y on x.
Yeah.
This is y on x.
Yeah, I don't know why, but this looks correct. Okay, wait. Okay, let me check this question then. Let me see
I
if
have applied simple unitary method in this,
okay,
and I got the same answer.
you got the same answer. So maybe I'll I'll just see what I've done here. Maybe I've did something wrong, but okay. The answer should be correct because, yeah. But let me still check. Okay, I'll just check if that how should we derive this. Okay. So this is a slightly difficult question, but yeah. So for this, you need to know what formulas are we talking about, and then what all is known. So it would really help, given if you write it in terms of symbols, the mean, like what it's written here, and then what you need to find out. So what formulas would work best? What topic and subtopic are we talking about in this case? Yeah. So that is there. Okay. So which of the following statements is true? Event A is it's a whole number, y is an integer, and so this is said. So this symbol, it means it's a subset of. So x belongs to y. So every element of x should be present in y. Is that true? Right? Because integers are minus infinity to plus infinity, all the numbers like that. So 10, 20, 5, 6, minus 5, minus 3, and so on. And whole numbers are from 0 onwards. So this is true, right? And every set is a subset of itself, because all elements of this x are a part of the other x, right? So both the statements are true. Okay. Then two fair six-sided dice are rolled a single time. What is the probability that the sum of the numbers they land on is an even number, and at least one of the two numbers is a prime number, right? So you have two events, A and B, and the and here basically implies that you are interested in the intersection, right? So you can make a list of what all
Should
numbers
not
would
it
fit.
be 11 by 36?
It should be 11 by 36. Okay, let's make a list. So even numbers, and so this one, right? So even some of the numbers should be even, and one of the numbers should be prime, right? So I hope you have not missed 2 as a prime number, right? So 2, 2, 2, 4, 2, 6, 3, 1, 3, 3, 3, 5, 5, all the 3 options. This option with 4 also will be there, 6 and 2, and 1 and 3. 1. So this is 13, right? 6, 7, 8, 9, 13.
Yeah, by
Yeah.
16. That's correct.
So 13 by 36, right? Okay. Okay. Then consider the following set. A is all the factors of 30. Prime numbers less than 10. Even whole numbers less than 10. Yeah.
Could you please go to the ninth question?
Yeah.
Question mentioned about there is a probability that the sum of the numbers they land on is an even number. Means even number on the lower side.
Oh.
Then we'll get the
Okay.
odd number on the upper side.
Okay. No, that's too complicated. I can understand why you thought so, but
based on the statement, so land on the even number means even number should be on the ground side.
No. So land basically means it's how it's said. The dice landed on 5. So that means I got 5. Not 5 is on the downside. That is how it would mean literally, but that's not how it's used. If you would see the usage of the phrase the dice landed on this number, it means what number you see.
That means there is a chance of taking that statement also we can get the even other answer.
I don't know how to answer this, but
Of course, maybe sometimes that is a trick in the question.
Yeah.
So if we solve that, again we'll get some other answer. Of course, what you told just I also taking the same. I also considered the same thing while calculating. But there is a chance of land on is an even number. That is even number on the lower side. That means we will get a odd number on the upper side. Then again the calculation will.
So what is the relation? The opposite sides of the dice. How is it connected?
So we can't assume
that 7. We add them to 7.
It adds up to 7.
1 plus 6, 2 plus 5, 3 plus 4.
Okay. Yeah. Good. I mean, it's nice. That's also an option, but that's too complicated.
Of course, it is complicated, but based on the statement, we need to consider. Sometimes if we calculate in this way, and the trick point in that question maybe is land on the even number means so the even number on the lower side, that automatically the upper side we will get other number.
Okay, I see. Yeah. Okay. Thanks for pointing it out. But again, I can just say that things like this they were never discussed in the course, not even the slide test. And this is not a very common knowledge, right? So good to know. I mean, yes. So maybe if that is the case, then it would be added into the question that note the opposite sides of the dice, they add up to 7. And then in that case, even this phrase would be more
important.
It would be more elaborated actually. That the lower side and the upper side, it would be slightly more clearer. Yeah. Okay. All right. So then all the factors of 30, prime numbers less than 10, even whole numbers less than 10. So, right? So yeah, so only 2 is fitting. And so now I would just like to ask you, when they say all factors of 30, would you also include 6 and like 15 in this? 6, 15 and 10 maybe. Yeah, 6, 10 and 15.
Yes, ma'am.
Yeah?
Yes, ma'am.
Yeah, so
yes, ma'am.
1 would not be included because
1 is the factor of all numbers.
Okay. Yeah, so actually 1 will also be there.
We
So
need
yeah.
1 also.
Okay. So 1 and 6 and 10 and 15. Luckily, the answer stays the same, whether you include those or not. But yeah. So I will just mention these points that there are these confusions that just happen. So it's just important for both the sides of the course. They should know that how the questions are being understood by the students. So that better questions can be made and to avoid any confusion, especially in the exams. Yeah. All right. So that's it. Anything else you would like to discuss? I will check these questions. I'll let them know. I'll also check this question number 7. What derivation I've done. Not this one here.
The minus, why the minus they have done?
Yeah, that minus sign, question 5 I've noted. And in question 9, this dice and land phrase. And in question 10, even though the answer is not changing, but when they say factors, all the other numbers are also included. So yeah. Okay. So yeah, that's it for today then. The assignment deadline is next Wednesday. So
So we call end of the day, day off. So one thing I would like to ask for the very last question was that the 10th number, since the common was 2, the answer was 2. So in that case, so is it just we need to mention that the how
answer
many?
is n, right? So
Yeah, so the
number of elements in this. So that's just 1. Yeah.
Thank you.
Yeah. Okay. So I will just, where did it go? Yeah, I'll just stop sharing my screen. So do you have anything else that you would like to discuss?
Ma'am, so for the 10th question, can we even try the Venn diagrams also? That the third assignment which you just now shared about.
Yeah. So the thing is, then when you're saying intersection, you would like to talk about the elements which are therein, which are satisfying all the criteria, all the three options, right? What numbers are there, which is a factor of 30 also, which is a prime number less than 10 also, and which is a whole number less than 10 also, right? So actually, if we consider 1 in this, then the answer is going to be 2, right?
Yes, ma'am.
No, ma'am. Even prime number, that also is whole number. Even whole prime number, only 2.
No, whole number, 1 is also whole number, right? 1 is a whole number, 1 is a prime number, and 1 is a
But that is
factor.
not even. Ma'am, that is not even.
Oh,
One is not
even
One
whole
is not
numbers.
even.
Oh, sorry.
One is not
Even whole numbers. I'm sorry. Yeah. Okay. Okay. So the answer is unaffected. All right. So, okay. Yeah, fine. So, yes, so you can use Venn diagram, whatever you're more comfortable. You're writing, drawing, that's up to you. Yeah.
Okay,
So yeah, all right. Thank you for attending today's session. I hope this clarified
Thank
the
you.
course's topics for you. And I'll see you again next week. All right. Thank you. Don't
Thank
forget
you.
to submit the assignment. And for those of you who are interested in sitting for the final exam, I think the deadline is 21st of August for the registration. So, if you want, you don't miss that deadline. Okay. So, all right. Thank you so much. Good night. Bye-bye.
Thank you, ma'am. Good night.